भाइयों और बहनों, आज है 2 जून 2026 and till today's date 118 elements have been discovered by scientists. 118. Can you imagine? सोचो, you being a scientist, you have to study and give the properties of all of these elements. क्या तुम एक एक करके सारे एलिमेंट्स की प्रॉपर्टीज निकालोगे फिर लिखोगे कहीं पे? सालों निकल जाएंगे. It will take years, which is why at the time of the 19th century scientists were looking for ways to arrange these elements. कैसे? हमें ऐसा करना है. I will put some elements in a line. I will put some different elements in a line. All the elements in this line will have similar properties. All the elements in this line will have similar properties. All the elements in this line will have similar properties. And so I've categorized elements into lines or columns. Now, instead of studying all 118 elements, or at that time 56 to 63 elements, instead of studying all of them separately, I can instead study these lines. I can study these categories and generalize what the elements should look like or how they should behave. So now we travel back to 1829. In Germany, there was a scientist by the name of Doberheiner. He said that I can arrange elements. And उसने बोला कि I will put one element here, I will put one element here, and I will put one element here. He said I'll put three elements together and I'll call this a triad. I'm going to put lithium, I'm going to put potassium, and here I'm going to write 7, and here I will write 39. अब मैं क्या कर रहा हूँ, मैं इनका एवरेज ले रहा हूँ. 39 plus 7 upon 2. This is 46 by 2 or 23. And he said, मैंने यहाँ पे लिखा 23 and मैंने चुपचाप से 23 मास वाले एलिमेंट को लिया and I put sodium here. 7 is the atomic mass of lithium, 39 is the atomic mass of potassium, and the sodium, which is the metal in between, has the atomic mass of 23, which is an average of these two. So Doberheiner said that any triad you form where the middle element has the atomic mass as the average of both of them, of the other two, all three elements in this triad will have similar properties. Meaning, he said lithium, sodium and potassium will behave similarly. He gave this triad, people clapped for him. Show us more. So Doberheiner was like, okay, now let's move on. This is my second triad. I put chlorine, I put bromine, I put iodine. Iodine has mass of 127. Chlorine has mass of 35.5 and Br has mass of 80. Let's check if this follows my rule. 127 plus 35.5 upon 2. This does not look right. 81.25. So people were like, oh, this does not match. Br is 80. This is 81.25. But Doberheiner said, अरे लगभग match तो कर रहा है. It's almost the same. People clapped, but people clapped a little less. Then he gave more triads. He gave another triad. He gave another triad. He gave another triad. And then he got stuck. He was not able to form any more triads. His rule only worked for 15 elements. Keep in mind, this is in the time of 1829, and at that time there were 63 elements. Sorry, at the time there were 56 elements discovered. So out of 56, he only arranged 15, and so he was disappointed and his law failed. Now let's fast forward. Another scientist who goes by the name of Newland, he proposed his own law and he called it Newland Law of Octaves. Before we study this law, I want to first clarify that if you're going to be arranging atoms, if you're going to be arranging elements, you can look at two different things. So elements are made up of the same kind of atoms. And atoms are made up of two things. First is electrons, and the second is nucleons. Nucleons refers to whatever lies inside the nucleus. So for the sake of it, I'm going to write protons and neutrons. Now look, all of the mass of an atom is decided by the number of protons and number of neutrons, meaning all the mass is decided by number of nucleons, which means if I am using the nucleons to study about atoms, I can say that I am arranging the elements on the basis of their atomic mass, because nucleons tell us about the atomic mass. Atomic mass is just the number of nucleons. Whereas if I'm studying the number of electrons in each element and I'm arranging them using the number of electrons, that I can say that I am arranging the elements on the basis of their atomic number, because atomic number is just the number of electrons or number of protons. So up until now, Doberheiner used atomic mass. He arranged elements in increasing order of mass. You saw like Cl, Br, and I. Cl has mass 35.5, Br has mass of 80, and I has mass of 127. It's an increasing order of mass. In a very similar way, Newland also arranged on the basis of increasing atomic mass. And the funny part is, Newland actually was a very big fan of music. Music has 7 tones. One octave has 7 tones. Please sing along so I don't embarrass myself. He started putting elements. Now remember, now this is the time of 1865. So at this time we have 63 elements. This is a rough view on Newland's law of octaves. In music, after every 7 tones of sa re ga ma pa dha ni sa, of sa re ga ma pa dha ni, it comes back to sa, because the notes are the same but they're in a different pitch. So all the sas are treated equally. Similarly, in Newland's law of octaves, every element in sa must have the same properties. Every element in re must have same properties, and so on. Meaning, these have the same properties, and these have the same properties, and so on. This is lithium, sodium, and potassium. Do you remember the first Doppelheimer's triad? It was lithium, sodium, and potassium. Both of these lists conclude that lithium, sodium, and potassium must have the same properties. This is just confirmation that, what Doppelheimer said was correct, but just incomplete. The problem with this and why it failed is, firstly, hydrogen is on the same line as fluorine and chlorine. Hydrogen does not share properties with these two elements. In fact, to this day, we have not been able to correctly map hydrogen on the periodic table. His law worked fine until calcium, but after calcium, it failed, because the first element after calcium is in this table is chromium, and chromium does not match with these properties of boron or aluminium. Chromium does not match with these. Manganese does not match with these. The point of this was that one line should have same properties. These don't have same properties as this. Cobalt and nickel being on the same spot. Newland did this intentionally in order to fit elements into the list. But it's just wrong, because firstly, cobalt and nickel have different properties amongst themselves, but also they have different properties in comparison to chlorine and fluorine. These are gases. Cobalt and nickel are metals. So how can they be the same? How are they in the same line? He put dissimilar elements in the same group. So unfortunately, this meant that this law also failed. Fast forwarding only 2 more years. Fast forwarding only 3 or 4 more years. 2 scientists. First is Lothar Meyer, and the second is Mendeleev. Now, Mendeleev is a very popular name. In fact, on the modern periodic table, Mendeleev has an element named after his name, Mendeleevian. His table is not the one we use today, but and the reason I'm covering both of these is these happened almost at the exact same time, and both are technically correct, just lacking. And no, Mendeleev and Latimer did not know each other. They were not friends or did not have any connections. Their research was done independently. But let's first look at Latimer. Latimer had his one of the most unique approaches in order to arrange elements. First, he looked at this list and he said, "Atomic mass, I choose you." Just like the previous two guys, he once again chose atomic mass, and what he did was he looked at an atom. An atom has a positive nucleus and an orbital. This is, let's say, 1s. 1s orbital can have 2 electrons. So when it has 1 electron, its size, he looked at its size and he said its size is something, let's say it's some v volume. Let's say the volume of this 1s orbital is v. If I add another electron, well, there's more negative charge and that will be attracted towards the nucleus. So the addition of the extra electron will cause the size to shrink slightly. The size will become smaller than if there was only 1 electron. So it will be v dash will be less than v. But look at this, the second I add another electron, if I add a third electron, there's no space here. So the third electron goes here into the 2s orbital. And you see the 2s orbital, when the electron came, the volume of the atom immediately increased, and increased by a large amount. Earlier the volume was just till here, now it's this whole thing. So he noticed that after a certain period, the volume will increase. And he made a graph. He did not make a table like everyone else. He made a graph. This is the, you have y-axis. और ये on the x-axis he put atomic mass. So यहाँ अगर तुम यहाँ जाओगे तो mass बढ़ेगा. And on the y-axis he put atomic volume. अगर तुम if you go here mass बढ़ेगा, यहाँ जाओगे तो volume बढ़ेगा. अगर तुम यहाँ से यहाँ गए तो mass बढ़ेगा, यहाँ से यहाँ गए तो volume बढ़ेगा, यहाँ से यहाँ गए तो mass बढ़ेगा, volume बढ़ेगा, यहाँ से यहाँ गए mass बढ़ेगा, volume कम होगा. And then he measured the mass and volume of every element and he plotted them on the graph. And then he made a curve. He made a smooth curve. And then he said, उससे ये बोला कि elements occupying similar portion of curve will have similar properties. I have put some of the elements on the board. Firstly, the elements that occupy similar portion of the curve will have similar properties. So in this case, the peak of the curve, this is where the atomic volume peaks. What we have sodium, we have potassium, and we have lithium, which is close to the peak. Then we have these guys, and these guys occupy the decreasing portion, meaning they occupy the part where the slope is negative. Slope being negative means the graph is dropping. Graph नीचे आ रहा है. कुछ elements है like this or this or this, जो कि which occupy the increasing part, meaning जहाँ पे slope ऊपर है, slope is positive. Yes. उसने बोला कि he said that these elements will have same properties, these elements will have same properties, and these will have same properties. And at this point, some of these elements have gotten a name. द एलिमेंट्स विच ऑक्यूपाई द पीक, वट एवर जो भी ग्रीन में है, दीज आर कॉल्ड एल्कली मेटल्स. जो भी ब्लैक से सर्कल है जैसे फ्लोरीन, क्लोरीन, ब्रोमीन, दे आर कॉल्ड हैलोजेंस. आपने कभी कार चलाई है या आप कभी बाहर तो गए होगे ना, जब बाहर जाता हो तो बाहर रोड होता है, ट्रैफिक होते हैं, कार्स होते हैं ना. आपने कार्स देखे, कभी बाइक्स देखे, स्कूटी देखे, उनके लाइट्स या तो व्हाइट होते हैं या येलो होते हैं. व्हाइट लाइट्स मोस्टली मीन्स एलईडीज. पर जहां पर आपको देखिए येलो लाइट्स, जो भी येलो कार्स में येलो लाइट्स होती है ना, उन येलो लाइट्स को बोलते हैं हैलोजेंस, हैलोजन लाइट्स. एंड हैलोजन लाइट्स बोलते हैं क्योंकि उनमें होता ही हैलोजन है. हैलोजन मीनिंग फ्लोरीन, क्लोरीन, ब्रोमीन, आयोडीन. एंड जो भी ये डॉटेड ब्लैक से रिंग से कवर्ड है, दे आर कॉल्ड एल्कलाइन अर्थ मेटल्स. एल्कली मेटल इससे बोलते हैं वी कॉल बिकॉज ये सब पानी में एल्कली बनाते हैं. एल्कली मीनिंग बेस, LiOH, NaOH सोडियम हाइड्रोक्साइड, KOH पोटेशियम हाइड्रोक्साइड, स्ट्रॉन्ग बेसिस. एंड मेटल्स है तो एल्कली मेटल्स. हैलोजेंस FCl, Bri, alkali metals. And look at this, lithium, sodium, potassium, LiNaK. क्या और कंफर्मेशन चाहिए? This is more confirmation. LiNaK, this was the first double hydrogen triad. वापस आ गया. मेंडलीव ने भी इसको देखा and he said atomic mass, I choose you. मेंडलीव कहता है एटॉमिक मास आई चूज यू. एंड उसने टेबल देखा, उसने बोला कि द पोजीशन ऑफ द एलिमेंट्स ऑफ इन द पीरियड, एलिमेंट्स की जो पोजीशन है वो एक पीरियोडिक फंक्शन है एटॉमिक मास का. मीनिंग इसका मतलब क्या है? इसका मतलब है आपको याद है एक बंदा था अभी, एक साइंटिस्ट थे अभी, नाम क्या था, न्यूलैंड लॉ ऑफ ऑक्टेव्स. उन्होंने बोला था कि आफ्टर 7 एलिमेंट्स प्रॉपर्टीज रिपीट होंगे. He said that after 7 elements properties will repeat. That's what's the meaning of period. Period means a interval after which something repeats. So जैसे एक फंक्शन है, फॉर एग्जाम्पल ये ग्राफ है अपना y इक्वल्स साइन x का. एंड अगर आप देख रहे हो ये ग्राफ में ये होता है पाई, ये होता है 2 पाई. 2 पाई के बाद रिपीट हो रहा है, सेम ग्राफ बना 2 पाई के बाद, फिर 4 पाई के बाद सेम बन रहा है. मतलब इस ग्राफ का पीरियड 2 पाई है. इस ग्राफ पे 2 पाई है, मतलब कि 2 पाई के बाद रिपीट हो रहा है. वैसे ही एटॉमिक मास भी पीरियोडिक है, एलिमेंट्स की प्रॉपर्टीज भी पीरियोडिक है. एंड पीरियोडिक फंक्शन है एटॉमिक मास का. एंड उन्होंने ऐसे अरेंज किया, यहाँ पे है 8 ग्रुप्स. उन्होंने देखा इंक्रीजिंग ऑर्डर ऑफ मास में. एंड नेक्स्ट तो कुछ ग्रुप्स में A और B सेक्शंस भी है. पता है सबसे ब्रेकिंग डिस्कवरी ये थी इसकी, it was that firstly Mendeleev arranged elements using valency. Valency means कि वैलेंस शेल में कितने इलेक्ट्रॉन्स है. कैल्शियम के आउटरमोस्ट शेल में 2 इलेक्ट्रॉन्स है. एंड जिंक में भी 2 है. जिंक में क्या होता है 4s2 3d10. आउटरमोस्ट कौन सा है 4s2. और पे कितना है 2 इलेक्ट्रॉन्स. सो इन सबकी वैलेंसी सेम है, इन सबकी वैलेंसी सेम है. H की 1 है, Li की 1 है, Na की 1 है, K की 1 है. बाय द वे Li, Na और K वापस आ गए और अब तो कंफर्म हो गया है ना कि सेम है. Alright bro, we get it now. Yeah, something like that. Just put the flies in the bag bro. Mendeleev ने गैप्स लीव किए हैं. यहाँ पे कुछ एलिमेंट सुना था जो हमको उस टाइम पे पता ही नहीं थे कि थे कि नहीं. मेंडलीव ने देखा कि इन दोनों के मास के बीच में गैप तो ज्यादा आ रहा है, तो उसने बोला कि बीच में कुछ तो होना चाहिए. समथिंग मस्ट बी हियर, क्योंकि इतना बड़ा गैप तो है ही नहीं किसी और में, पॉसिबल नहीं है. सो उसने ऐसा किया, उसने गैप्स लीव किए. एंड बाय द वे, इफ यू क्यूरियस, कैल्शियम और टाइटेनियम के बीच में आता है एलिमेंट, ये गैप सही छोड़ा है. दिस इज स्कैंडियम, बट स्कैंडियम तो पता ही नहीं था किसको. इनफैक्ट ये जो Al है ना, Al की प्रॉपर्टीज मैच करेंगे इस थर्ड के बी से, एंड सिलिकॉन की प्रॉपर्टीज मैच करेंगे फोर्थ के बी से. मेंडलीव ने कैलकुलेट किया कि प्रॉपर्टीज कैसे होनी चाहिए उस एलिमेंट की जो यहाँ पे आएगा, एंड जो उसने बताया था इट परफेक्टली मैच्ड विद गैलियम एंड जर्मेनियम, जो कि आज टेबल में इनके नीचे ही रखे होते हैं. एल्यूमिनियम के नीचे गैलियम आता है एंड सिलिकॉन के नीचे जर्मेनियम आता है. एंड ही मेंडलीव प्रेडिक्टेड दैट देयर मस्ट बी एन एलिमेंट विद सिमिलर प्रॉपर्टीज टू दिस विद सम पीरियोडिसिटी. का मतलब ये सिर्फ ये नहीं है कि प्रॉपर्टीज रिपीट करेंगे, उसका मतलब ये भी है कि अगर कुछ भी बढ़ेगा या इंक्रीज होएगा वो भी एक सर्टेन अमाउंट से होएगा. इट मीन्स जैसे मैं यहाँ से यहाँ गया, साइज अगर बढ़ेगा, एंड साइज बढ़ेगा ऑब्वियसली, क्योंकि दिस इज 2s1 एंड दिस इज 2p63s1. सो ऑफ नया चला गया तो ऑफकोर्स साइज बढ़ना चाहिए. व्हेन यू गो डाउन साइज इंक्रीजेस, बट इंक्रीज भी फिक्स्ड अमाउंट से होएगा. दैट्स व्हाट पीरियोडिक मीन्स. सो ये अगर ट्वाइस बढ़ेगा साइज, तो ये भी उसका ट्वाइस होएगा, ये उसका ट्वाइस होएगा, एंड समथिंग लाइक दैट, मे बी 4 टाइम्स हो गया. बट एक कंपेरेबल ऑर्डर से इंक्रीज होंगे ये वाला. एंड द प्रीवियस वन विच वाज Lothar-Meyer's curves did not fail, but they were suboptimal. प्रॉब्लम इस टेबल में प्रॉब्लम आया बिकॉज मेंडलीव यूज्ड एटॉमिक मास. जस्ट लाइक बाकी सबने एटॉमिक मास यूज किया, सबने ही गलती की है. मास ऑफ कोबाल्ट इज मोर देन निकल. सो पहले क्यों आ गया? मेंडलीव ने कोबाल्ट Mendeleev put cobalt here because it matches with these. And secondly, if he was arranging according to mass, he did not consider isotope. जैसे H का mass we know 1 होता है, but it's not always 1. H का mass 2 and 3 भी हो सकता है. This is deuterium and this is tritium. So table में he should have put something like this, H2, H3, but he did not. The position of isotopes was not defined. In fact, the position of hydrogen itself was not defined. H का position खुद define नहीं हुआ था, क्योंकि H के कुछ properties इनसे मैच कर रही हैं, मीनिंग लिथियम, सोडियम, पोटेशियम, जो भी एल्कली मेटल्स है उनसे मैच कर रही हैं, एंड बाकी प्रॉपर्टीज इनसे मैच कर रही हैं, फ्लोरीन, क्लोरीन, ब्रोमीन, आयोडीन अपने हैलोजन से मैच कर रही है. सो H का पोजीशन डिफाइंड था ही नहीं. एंड इन फैक्ट इन द मॉडर्न पीरियोडिक टेबल, आई एम गिविंग यू थोड़ा सा स्पॉइलर, उसमें भी डिफाइंड नहीं है. सो ये प्रॉब्लम आज तक है. बट Mendeleev had done a fantastic job because if he figured out the concept of valency, he left spaces, he created a layout which is easy to understand. Lothar-Meyer, it's fine, but it's not easy to understand using graph. But then came another scientist.